Okay, then we'll move on to next question. So this is GATE 2022 Life Sciences, section is Chemistry, question number 15. Which of the following is the correct statement about hexoses? Options are A. D-mannose and is C4 epimer of D-glucose. Option B. D-galactose is C2 epimer of D-glucose. Option C. D-glucose and L-glucose are diastereomers. And option D. D-glucose and D-galactose are diastereomers. This is the NPTEL online course reference for this question. Okay, this is pretty basic chemistry, right? So what are stereoisomers? We'll first begin with what are isomers. Isomers are what? Any chemical compound which has same molecular weight but different structure, right? The molecular weight could be same but the overall structure is same. And what are stereoisomers? So stereo means in space. Okay, stereo means in space. So even though they have a same molecular weight, so C6H6. Yeah, so let's consider the chemical formula for glucose, which is C6. Yeah, so this is the chemical formula for glucose. So we have different hexoses, right? They have different chemical, they have same this chemical formula, but the only difference is the structure. So hexoses, we have glucose, we have mannose and galactose, but these all three are different sugars, okay, because the OH is placed in the different position. So here we have a example with a glyceraldehyde. This is a ball and stick model. Okay, so this is a mirror image. So what is a mirror image? If I keep a mirror here, these two are the mirror images, right? So if the mirror images are, always remember that mirror images are non-superimposable. What do you mean by non-superimposable? So if I pick this L-glyceraldehyde and if I keep it on this D-glyceraldehyde, it won't be superimposable. That is, it won't be able to match. Because if I place this glyceraldehyde L on this D, what will happen? This OH will be placed here on H and this OH will overlap with this H. So these are non-superimposable. So always remember the mirror images. The mirror images D and L glyceraldehyde. These are the mirror images of each other. These are non-superimposable and these structures are known as enantiomers. Very important. So enantiomers are what? These are the mirror images of each other. So D-glyceraldehyde and L-glyceraldehyde are two different molecules. Okay. So inside the cell, we generally observe D-glyceraldehyde. We have D sugars, right? We have D sugars present in the cell, and D-glyceraldehyde is very different from L-glyceraldehyde. Okay. And these are the mirror images of each other and they are non-superimposable, and this is example of enantiomers. And enantiomers, the opposite of enantiomers is diastereomers. What are diastereomers? These are opposite of enantiomers. So these are non-mirror images. Okay, these are non-mirror images. It's exactly opposite of enantiomers, and these are superimposable. Right? What is the example of a non-mirror images and superimposable? Let's consider these glucose. So we have glucose in between. So these two are epimers of different aldohexoses. Okay, these are the epimers of glucose. So diastereomers, by examples. So diastereomers has an umbrella. Under that umbrella we have epimers, other different isomers. So diastereomers means the OH, the spatial arrangement of OH is different. Okay, and if we change that spatial arrangement, we'll come back to the original structure. So let's take an example. So we have a glucose here. Okay, so mannose is a C2 epimer of glucose. So when we change the spatial arrangement, by spatial arrangement I mean spatial arrangement of atoms. So this Fischer projection of mannose, if we change this, so this spatial arrangement, that if we flip this H to OH, if we flip this across a chiral carbon, so very important, all these isomers are a result of a chiral carbon. And what is a chiral carbon? Chiral carbon is which it is attached to all 4 different residues, right? This R1, R2, R3 and R4 are all 4 different. Here also this is one of the chiral carbon, and this chiral carbon C2 is attached to a aldehyde, hydrogen, hydroxyl group, and this whole group is different from all these 3. So this C2 is a chiral carbon. Okay, and glucose has how many chiral carbon? Glucose has 4 chiral carbons, right? Glucose has 4 different chiral carbons, right? And mannose is an epimer of glucose. How? So when we epimer at C2 position of that of glucose, so when we flip, if we flip this C2 hydroxyl group, we'll get a glucose. Okay, and this flipping is also not seen, this flipping is also not random, this spatial arrangement is also not random. These bonds don't change by their own, these can only be changed by enzymes. Okay, and we have to break a bond by breaking a bond, right? These are not freely movable, we have to break that bond and we have to form a new bond. Okay, so these are not random or freely movable, we need to break a bond in order to make glucose from mannose. Okay, so mannose, remember, it is a C2 epimer of glucose. Similarly, galactose is a C4 epimer of glucose. So if we flip the C4 carbon, if we flip the hydroxyl of the C4 carbon, the structure will resemble to that of glucose. Okay, the structure will resemble that of glucose. So the diastereomers are nothing but having different spatial arrangement in the space, but these are all completely different molecules. These are different molecules. Okay, and we cannot break a bond or a form bond easily. Okay, these are not freely movable, we have to break a bond, otherwise they cannot rearrange them among themselves. Okay, so epimers is an example. Epimer is a part of a diastereomers. Okay, there are other different types of diastereomers. So coming back to the question, so here they have asked which of the following is the correct statement. So D-mannose is a C4 epimer. No, we know that D-mannose is a C2 epimer of glucose, right? Similarly, galactose is C4 epimer of glucose. So these statements are wrong. D-glucose and L-glucose are diastereomers. So D-glucose and L-glucose we studied. D-glucose and L-glucose are mirror images, right? These are the mirror images, and mirror images are enantiomers. Always remember, mirror images are enantiomers, non-superimposable enantiomers. Always remember, Enantiomers and diastereomers are completely opposite. D-glucose and D-galactose are diastereomers. Yes, they are diastereomers because diastereomers forms it is a part of a epimer is a part of a diastereomers. Okay, it comes under the umbrella of diastereomers. So indeed, we can say that D-glucose and galactose are diastereomers, right? So all the epimers, always remember this, all epimers are diastereomers, but all diastereomers cannot be epimers. So all epimers, since diastereomers has different types of other isomers, epimer is a part of it. So we can say that glucose and galactose are epimers, which is under the umbrella of diastereomers. So we can say that yes, glucose and galactose are indeed diastereomers. Okay, so that's what I mentioned here. All epimers are diastereomers, but not all diastereomers can be epimer, right? Because there are other different types of diastereomers.